On this handout, we're going to look at several examples of problems using the ideal gas law. You are highly encouraged to work as many of these problems as possible on your own. If you already feel comfortable using the equations to solve, go ahead and solve now before you watch any of the video solutions to the problems. If you don't feel comfortable quite yet, watch one or two or three of the videos and then go on, solve the rest on your own before watching the remaining video solutions. First, I want to tell you that up at the top of the page, you've got some of the constants that you'll be provided on your equation sheet for this material. You have the value of R with the units, you have STP conditions, and a number of pressure conversion factors. This is all information that will be on your equation sheet for an exam. In example number 1, it says what volume is occupied by 0.118 moles of helium gas at a pressure of 0.971 atmospheres and a temperature of 305 Kelvin. So with the ideal gas law, there's a lot of information in the problem. We have to understand how to use all of the information, so make sure you stay very organized as you read these problems. If it helps to use colored pens or highlighters to help you keep track of all of the information, do that. So in this problem, we're asked to solve ultimately for the volume. The pieces of information that were given to us in the problem are moles. We know that the identity of our gas is helium. We know that the pressure of our gas is 0.971 atmospheres, and we have a temperature of 305 Kelvin. For the ideal gas law, we know that PV equals nRT, so that when we solve the ideal gas law for volume, we're going to have the equation that you see here. Volume equals nRT over P. So when we look at the ideal gas law, we have it solved for volume, we understand the information that we need, and we understand what we're looking for in the problem. As I check all of the variables that I'm going to need, moles was given to me, R is a constant, temperature was given to me in units of Kelvin, my pressure was given to me in units of atmospheres. That means I have everything I need to plug into the equation and I can solve. When you plug into the equation for moles, 0.118 moles, our value of R, 0.082057 with units of liters times atmospheres per mole times Kelvin, our temperature of 305 Kelvin, divided by our pressure of 0.971. When you solve, you get 3.04 liters. It's very useful for you to plug all of the information in with units. That will give you a check to make sure that you've done your algebra correctly when solving for the variable. So as I look at this information, my units of moles cancel moles from R. My units of Kelvin cancel with the Kelvin in my constant, and my units of atmospheres cancel with the atmospheres from the pressure that was given. That means that the units that I have left are liters, which is exactly what I'm looking for my volume, and my final answer in this problem is 3.04 liters. Question number 2 says, what is the pressure in a 15-liter cylinder filled with 27.1 grams of oxygen gas at a temperature of 302 Kelvin? So once again, we have a lot of information that we have been given in the problem. Ultimately, we're looking to solve for our pressure. We're given a volume of 15.0 liters, so this is our volume. We know that we have 27.1 grams of oxygen gas. This we will have to convert in order to get to moles. We have a temperature of 302 Kelvin. So that as I look at the information that I've been given and I look at what I've been asked for, my volume has units of liters, which is exactly what I need to plug into the ideal gas law. My temperature has units of Kelvin, which is also what I need. But my 27.1 grams of oxygen gas will need to be converted to moles. And so before I can begin the problem, I'm going to take my 27.1 grams of oxygen gas and I'm going to multiply by the fact that 1 mole of oxygen gas has a mass of 32 grams. Don't forget that oxygen is one of your 7 diatomics. And also make sure you remember your diatomics because 5 of the 7 diatomics are gases. That's going to be very important as we continue to go through ideal gas law problems. So that when we do the conversion for our mass of oxygen to moles, we get 0.847 moles of oxygen gas. From here, we now have all of the information that we need in order to plug into the ideal gas law. If PV equals nRT, and I solve my ideal gas law for pressure, that means that my pressure is going to be equal to nRT over V. So I'm going to plug in to this equation my 0.847 moles times 0.082057 liters times atmospheres per mole times Kelvin times my temperature in Kelvin of 302 divided by 15.0 liters as my volume. When I put all of that into my calculator and solve, I get an answer of 1.40 atmospheres. As I follow all of the units in that problem, my moles that I plugged in cancel with the moles in my value of R. My Kelvin for my temperature cancels my Kelvin. My liters cancel, and I'm left with atmospheres, which is exactly what I need for a pressure calculation. So far I've gone through the first 2 problems on this handout. There are 4 more problems. I want you to pause the video and try the remaining problems if you have not already done so. Question number 3 says, a piece of dry ice, which is solid carbon dioxide with a mass of 0.895 grams, sublimes into a balloon. What is the volume in milliliters of the balloon at a temperature of 22 degrees Celsius and a pressure of 742 millimeters of mercury? So there's a lot of information that has been given to us in this problem. Ultimately, we are looking to solve for a volume in units of milliliters. As I look at the information that I have been given, the first piece of information that I have been given is my 0.895 grams. I'm going to need to take this information and I'm going to need to convert from grams to moles in order to plug into the ideal gas law. The next piece of information that I have been given is my temperature. I'm told that it's 22 degrees Celsius and I need Kelvin for the ideal gas law, so that means that I'll need to convert my 22 degrees Celsius to Kelvin. Finally, I also have a pressure of 742 millimeters of mercury, and for the ideal gas law I need my pressure to be in units of atmospheres, so I'll need to do a conversion on my millimeters of mercury to atmospheres. So before I can solve for the ideal gas law, there are several conversions that I will need to do. First, if I start with a conversion from my 0.895 grams of CO2 to moles, I'm going to need to use the molar mass. You can calculate the molar mass of carbon dioxide to be 44.01 grams. When you do the conversion, you find that you have 0.0203 moles of carbon dioxide. Our pressure given to us was 742 millimeters of mercury. That needs to be converted to atmospheres. At the top of this page, you have several pressure conversion factors, including the relationship between millimeters of mercury and atmospheres. 1 atmosphere is equal to 760 millimeters of mercury, and so when you convert from millimeters of mercury to atmospheres, you should get 0.976 atmospheres. My temperature was given to me as 22 degrees Celsius. I'll need to convert that to Kelvin, so I'm going to take 22 plus 273.15, and with significant figures, that gives me a temperature of 295 Kelvin. So now when it comes to the information in this problem, I know my mole values, so I'll plug that in for moles. I know my pressure with the appropriate units, so I'm going to plug this in for pressure. And I know my temperature with appropriate units, so I'm going to be plugging that in for temperature. And all in all, I'm going to be solving for volume. When I solve the ideal gas law for volume, V is equal to nRT over P. As I plug all of the information I just found into the problem and solve, I find that the volume that I solve for in the ideal gas law is 0.503 liters. My question specifically asks me for my volume in units of milliliters, so I'll need to do a conversion to milliliters. And the final answer that I get is 503 milliliters.